Implementation of lazy learning algorithm using XL8ML, Part 1. XL8ML is a powerful parsing and data manipulation language that gets you data in the format you need, and its state-of-the-art machine learning functions allow you to perform advanced predictive analytics while remaining within Excel work environment. Have you ever wondered how companies like Netflix and Amazon recommend you different movies to watch and things to buy? Well, won't you be surprised if I say these companies apply a machine learning algorithm on a data gathered about the movies you have watched or the things you have bought on their website? In this video, we will explore the implementation of K-nearest neighbors algorithm, also known as lazy learning algorithm, using XL8ML software. Before we discuss about KNN, let's first understand what supervised learning is. Here the algorithm learns from labeled data and determines the label for the new data by understanding the patterns of the unlabeled new data. Supervised learning can be divided into regression. Numerical value is predicted by observing previous values. You can check out this in our previous video for understanding regression better. Classification, the category of the data is predicted. K-nearest neighbors algorithm is a supervised learner that is used for both classification and regression problems. In Part 1, we will see about KNN as a classifier. KNN uses the entire dataset in its training phase. Whenever a prediction is required for an unseen data, it searches through the entire training dataset for K most similar instances, and the data with the most similar instance is finally returned as the prediction. KNN is considered both non-parametric and an example of lazy learning. Non-parametric means that it makes no assumptions. The model is made up entirely from the data given to it rather than assuming its structure is normal. Let's get started on the implementation. We are using the social network ad dataset. The dataset contains the details of users in a social networking site to find whether a user buys a product by clicking the ad on the site, based on their salary, age, and gender. Now let us load the dataset into Excel. This is how the dataset looks after loading into Excel. We need to separate out the individual columns in order to analyze the data. This can be done using XL_S_split input range, delimiter, trim, function from XL8ML software. Once we do that, we get the desired format. The dataset is split into training and testing dataset randomly in 80-20 ratio. Let us give a name for the training model. Let it be train. Let us apply the function XL_ML_KNN_classifier_train model name, input range, output range, weight, K, over the we get the train model in cell N3. We will be considering this moving forward for other calculations. Now let's predict whether a person will purchase or not for the test data using XL_ML_KNN_classifier_predict, trained model, input range. Now it's time to evaluate the model we have built. We can use metrics like accuracy score, precision and recall to evaluate the performance. First we need to understand what these metrics are. Accuracy. Accuracy is the ratio of correctly predicted observation to the total observations. True positive is the number of correct predictions that the occurrence is positive. True negative is the number of correct predictions that the occurrence is n. Precision and recall. Precision is the fraction of relevant instances among the retrieved instances, while recall is the fraction of relevant instances that have been retrieved over the total number of instances. F1 score. It is the weighted average of precision and recall. XL8ML software offers these metrics for evaluation purpose. The accuracy score can be calculated using XL_ML_accuracy LHS, RHS. We get an accuracy score of 0.78. Our model has performed well. The precision and recall can be calculated using XL_ML_precision LHS, RHS, and XL_ML_recall LHS, RHS, respectively. We get precision of 0.60 and recall of 0.68. The question that precision answers is of all customers who are labeled as purchased, how many actually purchased? High precision relates to the low false positive rate. We have got 0.60 precision. He question recall answers is of all the customers who truly purchased, how many are labeled by the model as purchased? We have got recall of 0.68. Both metrics are looking good for this model as they are above 0.5. The F1 score can be calculated using XL_ML_F1 LHS, RHS, beta, where beta is a positive real factor. We get 0.63. F1 score gives us a representation of both precision and recall. We have a good score for the model built. Please do check it out at the link given in the description. Stay tuned for part 2 where we will build a KNN regressor.